Hello teacher, I am student at Ho Chi Minh City University of Technology and Education, Faculties of Mechanical Engineering. The title of presentation is Application of CAD in the Design of Machining Process and Tooling Device for Flange. Introduction. CAD tool is important in manufacturing technologies. CAD tool automates the manufacturing process, saving time, energy, cost, making production flexible, improve technical skill and reduces interaction time, reduce the number of technical staff, saving material, machine time tend to optimization algorithms. However, it takes a lot of time and money for a CAD project and user training takes a long time and costs a lot. Methodologies. Material. The material used is stainless steel grade 174. Why? It is the most widely used steel. It has high toughness, strength, corrosion resistance. Table 1 showing the composition of the material. Body model of Flange by face and cast. In my 1 and CAD plans. In my 2 body top and front view of the flange top. In my 3 body model left view of the flange top. Mold design and assemblies. The CAD plan were exported in Pro East assembly models. A 5 workpiece of specified dimensions were created. The sprue, bin, screw were separately modeled. Pay on standard size set for a mold assemblies. Components were assembled using the Pro Engineer. In my 4, an explore and explores assembly view of the molds. Computation of machining parameter. Flange processing method milling priming. The spindle speed for the milling operation. You can see the recipe below, where N spindle speed, V cutting speed, D is cutter diameter. V is selected at 150 means and D 60 mm. This selection will pay on the material property and the cutting tools. Basic time of milling operation. You can see the recipe below. T basic time in minutes. L length in millimeters. A approach. F fixed rate. And it is expressed as you can see the recipe where F is fixed tools and number of teeth of the cutter. F word is selected as 0.50 mm tools and ends 10. You can see the recipe where this would the diameter. Basic time for drilling and priming time. You can see the recipe below where 6 D 2 freeze. D is diameter drill of the holes. V 0.5 drill point angle. Auxiliary time is presses. You can see the recipe where TA is the auxiliary time, T is the basic time in minutes. Operation time in days. You can see the recipe. Table 2 process servants. Design of dedicated feature for machining the parts. Design feature for machining the flange top. Analytical designs, part modeling and feature assemblies. The analytical design of the feature entails design of base block or plates, base block, K, pins, protective plates, pin, auxiliary support as well as sprue. Part modeling is concerned detail parts of feature. In my 5, part of the first feature, it may 6 idea from view of the feature. To design the first feature for milling, drilling and priming of the nice hole. A pipe block of dimension 800 mm by 500 mm were created to maintain spatial relationship between the components. Two blocks of V-shape were designed. One their pieces of the order immovable. In May 7, hide the third view of the feature. In May 8, body of second feature. In May 9, hide the front view of the feature. In May 10, hide the third view of the features. In May 11, hide the side view of the feature. Mold cavity simulation. The molds were made up for components. Its ingredient has machine using Mastercam Napoleon. In the Mastercam Napoleon, the IGES formats were transformed, rotated and translated in order to convert the units. Ensure that the z-axis is vertical. The machine boundary was set up a rectangle created. The flange is within machine boundaries. In May 12, toolbars. Machining parameters such as spindle speed, pitch rate, retract angle were entered. The CAM software were placed to obtain the toolpath and the finish path. The finish parameter have been inputted into Mastercam Napoleon, the simulation of the flange. In May 13th, finish operation. Research and discussion. CAD is a useful tool in the manufacturing industries. Components difficult to manufacture can be easily made without a truly converting the raw material. Third, saving time, cost, and energy. CAD has been applied to model the flange, its mold and feature for manufacturing. The two dedicated feature designed and created used to manufacture thousands of flange on factors that affect the durability of the feature have taken into consideration. Such factors include support, clamping, positioning, and feature parties. From the two machining operation time for the various machining process were provided. The milling operation at the diameter of the workpiece elastic, the operation time is higher and vice versa. The remaining and priming operation increasing diameter of the workpiece increase the operation time. Operation time for the priming is higher than the order operation time because lower spindle speed. A reasonably smaller machining operation time indicates a faster production rate, thus saving energy, time, and cost. For the validation of the simulation, C and M codes path programming should be brightened, and the brightened path program is executed on the computer machining center. This would give the real or a toolpath of the simulation model. Conclusion. CAD tool applied in the design of machining process, tooling device for a plant top. A CAD tool Pro E has been applied in the creation three-dimensional model of the flange. The same software were used to design and create a mold. Its component parts for the manufacture of the modular parts, machining process for the production of the parts have been designed. Feature to support and locate. Thank you, listen to me.